Hey there! Today we're looking at how to multiply two polynomials together. To get started, let's take a look at multiplying a binomial with a monomial. How do we do that? So here's a binomial. How about some expression a plus b? And we're going to multiply that with a monomial, let's say the number 3. Okay, so what will we get here? Well, all we have to do really is just distribute this 3 into the parentheses. We will get 3a plus 3b. And that's it. We're done. We know how to do distribution. So multiplying a binomial with a monomial, that's pretty simple. What, though, do we do if we have a binomial, a plus b, multiplied with another binomial, c plus d? Two binomials multiplied together. This looks a little bit more complicated, right? So how do we want to think about this? Well, what we can do is we can sort of imagine what we're going to do is let's set some new variable x equal to c plus d. Okay, if we do that, so we're sort of renaming this term here x. So if we do that, we're going to have essentially a plus b multiplied by x, and this is now just a binomial times a monomial, and so we know what we're going to get, just ax plus bx, just like what we had before, okay? This kind of multiplication we can do. Now we just substitute back in what is x. Well, x is going to be this c plus d. So let's write what we get now there. This is actually going to equal a times c plus d plus b times c plus d. And now we can do the same step again. Distribute the a in there and distribute the b in there. We're going to get some ac plus ad plus bc plus bd. Okay, this is what we're actually going to wind up getting at the end when we do this entire multiplication of two binomials together, okay? But that's kind of a really long way of doing this. So what we want to do is have more of a shortcut, right? A shortcut way to do this kind of polynomial multiplication. So let me copy what we've got here, and let's think of a new way to do this. All right, so now that we have these two binomials, we want a shortcut way of multiplying them together to reproduce what we just did over there. What I like to think of is sort of taking the first term a, multiplying it by the entire second polynomial, and then you add b times the entire second polynomial. And if you had more terms here, you could keep doing that. You could keep repeating this process if you had a trinomial or a quadrinomial, whatever you want. And so essentially we will get a times c plus d, right, plus b times c plus d. And that's exactly what we saw we got over here when we went through this whole annoying process by using this kind of x substitution thing, right? And of course, if we do this, then we distribute everything through, you know what we're going to get this. So let me write that down here. We're going to get some kind of AC plus AD plus BC plus BD. Now, how do we remember how to do this? Well, there's sort of a mnemonic that we have for multiplying two binomials together. The idea is a times c is really this a times this d. It's the first term multiplied by the first term. Okay, so the two first terms multiplied together. So we label this with an F, the two first terms. Next we have a times d. That's the sort of the outer term multiplied by the other outer term, if you think of it that way. And so we use the letter O for the outer terms multiplied together. And then we have b times c. Well, that's b times c. These are sort of the two inner terms, right? You have the two outer terms, you have the two inner terms multiplied together. And so we use the letter I. And then finally, b times d. Well, this is sort of the last term of the first polynomial multiplied by the last term of the second polynomial. And so because it's last, we use the letter L. And so we call this method foiling, right? We say we're going to FOIL these two binomials together. And that's just a very common process that we're going to do again and again. And we'll just say we're going to FOIL them together. So it's the first, going to have the first times the first, right? Then you get the outer times the outer, inner times the inner, and then the last times the last. Okay, so this process here will allow you to sort of shortcut the whole process in multiplying two binomials together. Let's take a look at a practice problem here. All right, we have two binomials here that we're going to multiply together, and let's begin by multiplying these two first terms together. So that'll give us a 4x times a 2x. And then we're going to multiply the outer terms, so that's going to be a 4x times a negative 6. And then we're going to multiply the two inner terms, so that'll be a 1 times a 2x. And then the two last terms, so that'll be a 1 times a negative 6. There we go. Okay, so this was essentially our first times first, outer times outer, inner times inner, and last times last. So this was the FOIL method that we just looked at. Now we just need to simplify this, right? So if we simplify this, we're going to get, this will become an 8x squared. This will become a minus 24x plus 2x, and then finally a minus 6. And we can just simplify this a little bit further. We can combine these two like terms that were in the middle here. We'll wind up with an 8x squared minus a 22x minus a 6. And there we go. That's going to be our final answer right there. Okay, let's try another one, a little more interesting maybe. So here we have another set of two binomials that we're going to multiply together, but we've got some radicals involved. So let's remember our rules on how to deal with radicals. So once again, let's do this. So we're going to have the first times the first. That'll be a root 2x times root 8x. Plus the two outer terms. So that'll be a root 2x times a negative 4. Plus the two inner terms. So that'll be 3 root 8x. And then we're going to add multiplying the two last terms. So this will be a 3 times a negative 4. Okay, so that's what we'll get here. Let's try and simplify. Okay, so if we simplify this, we're actually going to get radical 16, aren't we, right? So we can call this rad 16x squared. Okay, the x's, they multiply together. Here we're going to get, this is, well, this will be then a minus 4 root 2x. And then here, this becomes a plus 3 root 8x. But I don't want to write it as a root 8. Instead, I'm going to write the prime factorization of 8, which is actually 2 cubed, right? And then finally here, I'm going to get a minus 12. Okay, now, why did I do that? Well, I want to simplify this further. Okay, so first I see this root 16. That's going to be, well, the square root of 16 is just 4. Right? So this becomes a 4x squared. Here I have this minus 4 root 2x. And then here what's going to happen is, this is essentially 2 squared times 2. And so the 2 squared I can take out, and I'll just be left with the root 2 over there. And so this becomes a 3 times 2, which is a 6 root 2x minus 12. And I think there's one final simplification step where I can combine these two like terms because they both share a common factor of x. I will wind up with a 4x squared plus 2 root 2x minus 12. And that should be the final answer here for this second example problem. Let's try another one that's a little more complicated. And here we're actually going to be multiplying a binomial with a trinomial. Okay, so this one we can't FOIL. Okay, in this way we just have to sort of brute force it, going step by step. What we're going to do is we're going to take 3x multiplied by all of this plus 8x multiplied by all of this. Okay, that's the process that we're going to use here. So let's do that, right? So we're going to have a 3, let me use white, a 3x times 2x squared minus 3x minus 5 plus 8 times all of that, okay? And that's how we're going to break this down. Now, once we've done this, this is just a monomial multiplied by a trinomial. So I can just distribute that 3x in. I can just distribute that 8 in. Okay, so let's do that. Let's distribute this through. We're going to get here 3 times 2 is going to be 6x cubed. Here we'll have a minus 9x squared, and finally a minus 15x. Okay, that works. And that's essentially one polynomial, and then we're going to add that with another 8 times 2x squared. That'll be a 16x squared. Here we'll have a minus 24x, and finally a minus 40. And now we have to add these two polynomials together. I'm going to use the vertical method. I kind of prefer that. So let's grab this, and then grab this polynomial, and we are going to now add these two together. But notice they're not lined up correctly, right? This is an x cubed and this is an x squared. So actually what I have to do is I have to shift this over to here, okay? And now it should work. Let's bring that line over. Okay, now we can add this together. So we're going to get a 6x cubed. This will be, what is this? A 9, it's going to be a 7, right? So minus 7, plus 7x squared. Here we'll get a minus 39x and a minus 40. And there we go. That should be our final answer right there. So we can multiply a binomial times a trinomial. And now for extra credit, let's try multiplying two trinomials together. Here we are, two trinomials. We're going to multiply these together, and we're just going to sort of step-by-step brute force it, do each step in turn. So we're going to take x squared multiplied by everything plus 3x multiplied by everything plus 8 multiplied by everything here. Okay, that's how we're going to write this down. Let's do this. We'll have an x squared multiplied by 2x squared minus 3x minus 5 plus a 3x, again, multiplied by this polynomial here, and then plus an 8, again, multiplied by this whole polynomial here. So this is actually what we need to do now. We need to do all of these distributions, and then we have to sum everything up, okay? So let's rewrite this. Let's see what we get. So when we distribute this x squared into all of these terms, we're going to get here, well, this will be a 2x to the 4th power minus a 6x, minus a 3x squared minus 5x squared. Okay, so that first one, you're just multiplying an x squared in. And next we're going to distribute this 3x in. So 3x goes into here, and we're going to get 3x times 2x squared is 6x squared, right? And notice that I'm writing it under here so that I keep my like terms in the same column, aligned vertically here. 3x times negative 3x, well, that would be a negative 9x squared. And then finally, we're going to get a minus 15x, all right? And now the last one, 8 times 2x squared, well, that's going to be 16x squared. I just noticed this is wrong. This is a 3 and this is a 3. Okay, don't make that mistake. 16x squared minus 24x and then minus 40. Okay, there we go. I think that should do it. And now we're just going to add these three polynomials together. Now notice this is why I wanted to do it the vertical way, because I can add all three polynomials together relatively quickly, right? So here I'm just going to get, of course, a 2x to the 4th power. Here I'll wind up with a plus 3x cubed. What do we get here? So this is a 14. 16 minus 14 is going to be a plus 2x squared. And then here again, we get a negative 39x minus 40. And that, I think, will do it for our final answer there. All right, so that is how we can multiply two polynomials together. Of course, if you have a monomial multiplied by a polynomial, then it's easy. You just distribute that monomial in. If you have two binomials, we can use that FOIL method, that mnemonic where it's the first times the first, the outer times the outer, the inner times the inner, and the last times the last. And you just add up all of those terms. And then you can go bigger. You can multiply, trinomials, quadrinomials, however many terms you want. Just go step by step. You can brute force it, going term by term, multiplying into that second polynomial, and then summing up your final answer. All right, come back next time when we look at some very special product formulas. They're going to be very handy to remember. I'll see you then.